Okay, on the final B then, we will ask for the constant numbers between 35 and 41 or something. Okay. So if you're looking at all of these numbers, right, which one is missing, guys? Which one is not there? 37. Is 37 a prime number? It is, hey? If you think of factors of 37, it actually doesn't have any factors, just one and then 57. Okay. So basically, I've listed all of the numbers between 35 and 41 except for 57, the one that is high. All right, so C, they wanted you to write 500 as a product of its prime factors. So remember, you write the 500 there, and then you write the first prime number that you think that can go into 500. That's an easy one, right? We know that 500 divided by 2 is 250. Can I divide 250 by 2 again? Yes. That's really nice today of all day. Otherwise, staring at the fifteen the seats that I'm designing. I feel like giving both of you detention for the times because you know how I feel going. All right, 250 divided by 2 is 125. Can 3 go into 125? How do we check for 3 again? Can anyone remember? So you take the digits of the numbers, so 1 and 2 and 5, you add them together. What's that? 1 plus 2 is 3 plus 5 is 8. Is 8 divisible by 3? No. So then 125 also is not. Okay, so it was 5 all the way through. Remember, you can write your answer like this as well. You could have said 500 is 2 times 2 times 5 times 5 times 5. Mm-hmm. Okay, for D, this was a little bit trickier because yeah, it was, oh wait, why did I write 169? It was 676. Hey, sorry, just fix that quickly. So they asked you, I'll just check now what the wording of the question was again. They asked you to find, did I not just erase that? They asked you to find the square root of 676. Let me just check. Use prime factors to find the square root of 676. So guys, that means that you can't just type it into your calculator. Remember, you are going to have a calculator in the exam. So if you don't know what to do and you just say, okay, square root 676, the answer is 26, you're going to get 0. Okay, you have to follow the instructions. So whenever you have to use prime factors, you must do the prime factorization first. You must write that number as a product of its prime factors. So 676 divided by 2 is 338, and so on. All right, so 676 is 2 squared times 13 squared. That's the first thing. Now, if you take the square root of 676, you're basically taking the square root of 2 squared times 13 squared. Now, what happens when you have a square root and a square? They cancel out, right? So the square root of 2 squared is just going to be 2. And the square root of 13 squared is just going to be 13. Right, this is the only way in which you can do the square root of these big numbers using prime factors. Okay, then for revision 2, are we fine with D, guys? Yes. No, they can't ask you to do that. They can ask you maybe a 2 to the 4. Let's think quickly if they did that. If this was the question, if you had to find the square root of 2 to the 4, let's say, times 13 to the 6. Will you guys be able to do that? We remember. What do you do when you take the square root? Let's think to what is actually happening here, right? I know we've been saying that the square root and the square cancel each other out, but guys, what's actually happening is the square root of 2 squared. What number is on the outside here? The square root. It's a 2 actually, eh? So what you are actually doing, and we did this with algebra, is you will take the exponent and you will divide the exponent by 2. That's actually what you're doing. Right, so you're going to say, and I think we did write this even a long time ago. We actually physically wrote 2 divided by 2 like that. You don't have to. All right, but that's actually what you're doing when you square root something, guys. Whatever that exponent is, divided by 2. So if we have the square root of 2 to the 4, we're going to say 2 to the power of 4 divided by 2. You always take the exponent in the square root and you divide it by the number outside by 2. Times 13 to the power of 6. That's the exponent. We now have to divide that by 2. All right, so what is 4 divided by 2 for that first one? 2. And if we have 13, what is 6 divided by 2? 3. Right, that is quite a big number. I'm not sure what that is. It's 4 times 1, 6. We won't give you one that's this big. I just came up with this example just to show you. So this is actually 8,780. Okay, but don't worry, you won't get something like this if you have to calculate it by heart. I just wanted to show you guys the exponent divided by 2 thing. Okay, it does come up quite often in algebra, so I'm sure it will come up at some point in working. Okay, any other questions? All right, let's look at number 2, which was algebra. You have to simplify a whole bunch of things. And guys, the types of questions that we got in number 2, they were all mixed together, right? It was addition, it was multiplication, division. You can expect something like that in your exam as well. Okay, we're not going to give you only addition questions or only multiplication questions. You need to be able to do them mixed together. Okay, so when we add, we change the coefficient, the number in front of the variable, right? So how many m's do I have here? 1, 2, and then another 2, that's 4. So the answer is 4. Okay, this is a 1 mark question, guys. You will only get 1 mark for that. As in without a calculator. Is it on the worksheet? You would have to write the 6 and the 9 with the base of 3. I'm going to show you that one. With the middle to do that. All right, are we finding the 2a? 2b, you're not multiplying a whole bunch of things together. Guys, remember that these numbers actually have nothing to do with the exponent of n. Right? I get the feeling, I got the sense from questions that you guys were asking me the other day, that you were getting confused with the numbers in front and the exponent. They separate. Okay, so you're going to multiply 3 by negative 2. What's that? Negative 6. Now, what's negative 6 times 4? Negative 24. All right? So when you multiply all of the numbers, the coefficients of n together, you're going to get a number, and that number goes in your answer. Now you're going to check. Remember, guys, this was the exponent law that we wrote down. If you have a to the power of m times a to the power of n, they have the same bases, right? Can we remember what do we do with those exponents? We add them together, right? You keep the base the same, and you add the exponents, right? The base doesn't change. The exponents are added together. Well, you would, I mean, if you could add them here. Okay. So do we notice that we have three expressions here, or parts of the expression that have a base of n, right? That has an exponent of 2. What is the exponent of n here? 1. And that exponent is 3. So guys, what we're going to do, we have a base of n. So we're going to keep that base of n, right? Are we listening? Thank you. And you're going to add your exponents. 2 plus 1 plus 3 is equal to 6. And that is your final answer. Guys, these two questions are very different. This is an addition question. This is a multiplication question. You have to understand the difference. So let me know if I must go over something very well. And see what was happening was they gave you two terms that were not like terms. So could we actually add or subtract those two? No. So what you do then is you just rewrite the question as it is. Yes. All right, for B, that is a 6 I think up there. Now guys, we need to remember we're dividing, okay? But we still divide numbers in the same way. What's a negative divided by a negative? Positive. What's 12 divided by 4? 3. So that is still happening, guys. Now we look at the x's, right? The rule that we wrote down earlier in the year was if you have a to the m, and you're now dividing that by a to the m. So again, if they have the same bases, your answer is going to have that same base. You're going to take the top exponent minus the bottom exponent. Or, guys, you remember that we used to say it like this. We used to say, how many x's do I have at the top? If it's x to the 6, how many x's is that? 6. And what's the question? X to the 6, 6 x's, okay? At the bottom, I have 2. Where do I have 4? At the top or the bottom? At the top. How many more do I have at the top? 4, right? I have 6 at the top, 2 at the bottom. I have 4 more at the top. So I have one x to the 4 at the top. All right, as a fraction. You could write it with an over 1. It's just there's nothing new. All right, so you don't have. I'm just going to add that as well. So you can apply this like minusing rule. Or you can say there are 4 more x's at the top. All right, so that is going to give an answer of x to the 4. So sometimes it happens that you have more x's at the bottom, right? In fact, there's come up in one of the pictures, so then you have to have that x at the bottom of the caption. You look at that as well. Okay, E was another addition question, but they tried to trick you because they didn't write all the variables in the same way. Right? For the first term, it was x squared y, which is correct, right? Because x comes before y is meant to be in alphabetical order. Here they put them in non-alphabetical order. Okay, so you can see what I did. I just swapped them around, right? X squared would come first and then the y. Do we now see that these are like terms? Even though at first glance maybe they look like they were not. Okay, they actually are like terms. And in the last term, they didn't simplify this. It's full time. We have 2, and then what's x times x? X squared. And we have a y. So now we can see that that is actually also, all 3 of them are like. So they're all like terms, guys. You don't change the variables. It's going to stay in x squared y. Right? When you're adding, the variables stay the same. The number in front changes. So what's 2 plus 3? 2 plus 3? 5 plus 2 is 7. But guys, like I said, the variable at the end of that term stays, those 2 variables actually stay the same. When you're timing, then you're going to change your exponent. When you're adding, it stays the same. Okay, for if, right, in the brackets, if we remember BOSMAS, right, it says brackets first. Okay, can I do something in the brackets here? Are these 2 nice terms? No. So now what's the next thing that we're going to have to do? Multiply the 3 by both terms in the bracket. So 3 times 4 is 12, and then there's an x, right? Positive times a negative is a negative. 3 times 2 is 6, and then you have a 1. And in the answer, those are also not like terms, so you can't do anything else for that. Oh no, so it's a number and a number. If it was an x and an x, then you would. Okay, are you feeling a bit clearer now that we've gone through these questions? Yeah, there were still some more. So in revision worksheet 2, number 1, I actually haven't written the answers down. I'm going to do them now with you step by step. Right, so that was number 1. Also some algebra questions. And guys, we haven't spoken about these types of questions where you have a whole bunch of things in a bracket. Yes, Shannon? You can? Yes, good. So we're going to have to square both of the things that are in this bracket, right? What is 2 squared? 2 squared is 4. And then guys, when it comes to exponents inside a bracket and outside a bracket, what you have to do is you have to times it. Okay, yes. Oh, wait. Okay, I'll just check with me. I think this next one. I didn't get another one, but you guys will have to do it. Should I check the same? Yeah. So that's 1.9. Okay, it's a word. I don't know. I think it's so let's do one. Oh, so you're going to take one. Okay. All right. Thank you. Is it on the final? Is it raining at the end? Oh, is that the final one? Yeah, they're saying this. Okay, I'll show you at the end of the lesson. Otherwise, you're also going to forget between now and then. So just all right. Are we fine here? So just new venue for grade assembly, but I'll show you that at the end of the lesson. Okay, so 2 squared, and then guys for this, because what this actually means, can we listen please? P4 is being squared. What actually happens when we do that? I'm just showing you. When you're squaring something, you're actually multiplying it by itself, right? Do you remember that? So this is actually what's happening. You don't have to write it down. I'm just showing you why we're timesing them. Now, if you have the same bases, what do you do with the exponents? You add them, right? And 4 times 4 is 8. But a quicker way of getting to 8 is just to take the exponents inside the bracket and outside the bracket and times them together. So 3 to the power of 8. Guys, there are lots of little rules. You're going to have to memorize them. If you don't know them yet, you're going to have to before your exam, right? Otherwise, you're not going to be able to do these questions. So you add. All right, the next one was an addition and subtraction question. So we need to look for like terms. We do have like terms here, 7x squared and negative x squared. Remember, when we're adding and subtracting, we don't change the variable. So the answer is going to have an x squared. But what is 7 minus 1? 6. So we're going to have 6x squared. You don't change the variable when you're adding and subtracting. Now, the other like terms that we have is we have 2 x terms. So we have a negative 6x and a positive 6x. That's just those two cancelling them out. Negative 6 plus 6. That gives you 2, 0. All right? So that will just be 0. So this is actually your final answer, guys. Because these two, that's equal to 0. You can leave your answer with a plus 0. You can write plus 0 if you want to, but then you have to say as your final answer, plus 6. Yeah. No, no, that's one of those places where you don't have to say it. All right, guys, for the next one, this is our one last question. And I'm curious to know how many of you actually minus first and then times. You have to multiply first, guys. So we're going to do negative 5y. That one stays on its own for now. We first have to multiply. What is it? Negative multiplied by positive. Negative. 2 times 3, 6. Y times y, y squared. Are those like terms? No, so that's the final answer. Okay, it's E. We're not dividing, guys. What's happening here? Negative divided by positive is a negative, right? So we can write that at least. Now, what is 4 divided by 8? 8 divided by 4 is 2, but the 4 is at the top, eh? What's that actually? 4 over 8 is a half, isn't it? 4 goes into itself once and into 8 twice. So then I'm going to have a fraction with a 2 and possibly something else at the bottom of the fraction. Okay, the 1 would have to be at the top, but if there's something else at the top, then we don't have to write that one. Okay, you can maybe just put a little note here at the bottom. 4 over 8 is a half. Okay, so that's why I have a 2 there at the bottom. But what else do we have here, guys? We have x's. How many x's do I have at the top? 2. How many at the bottom? 1. Where do I have more? At the top. How many more? 1. I have to put an x, 1x, x to the 1, essentially, at the top. Okay. What's up? Yeah, so you did 8 divided by 4 instead of 4 divided by 8. Okay. Yes. Yeah, that's the final answer. If you want to, guys, you can also write it. I don't think you guys would have because it's not how we did it in class, but you can write your answer like that as well. It does mean the same thing, negative a half, and then x squared divided by x is just x. So you can write it like that if you want to. But that's the final answer, guys. We're not going to do anything else from this part. Okay. Yeah. You can say something. I'm nervous. That was for a reason. Because I did that and I did the choreography. All right, guys, let's go. Okay. Guys, for number 3, I really want you guys to be able to get these marks. These count as knowledge marks, right? Meaning these are like the marks that everyone should be getting. But it's very important that you know what all of these words mean, right? So if they're asking for the degree of the polynomial, many of you were asking me what that means, which is fine because we did it a long time ago. But please, for your exam, you have to know what that means. Okay, the degree, if you forgot, please add it in there. Please write it down. It's the highest exponent of the variable. I didn't write there it's the highest exponent of x because you might have an a or a y or something else in your equation or your expression. Okay, so I can't always be x. So whatever your variable is, the highest exponent of that is the difference. And you can just write the number, guys. You don't have to, obviously this is not a part of the answer. This is just a little note of what degree actually means. Do we agree that the highest exponent of x in this expression was 5? So that is the degree. Okay, you can just write 5. That's your answer. Just 5. No units, no sacred, nothing, just 5. Okay, just for nothing. Yeah. No, you just have to say 5. And they might, yeah, because the definition of degree is that it is a polymer. Okay, so yeah, it might be like a double meaning. Alright guys, how many terms does this polynomial have? Remember that terms are separated by pluses and minuses. So that separates terms, and that. So we have 1, 2, 3, 4 terms. And then actually guys, the sign goes with the term, right? You know what I mean? So if they ask you, they can ask you this, what is the third term in the expression? Negative 8x. Okay, you always have to take the sign with it. Even though we're circling the signs to say, okay, this is separating, the sign goes with that term. Okay, that's very important. Okay, yes. Unless you're counting the sign in front of the first one. But yeah, we'll do one. Alright guys, we'll see, is the polynomial written in ascending or descending order? Now for that, you look again at the exponent of the variable, right? Let's look at the order in which these terms are written. We have 5, then we have 3, then we have 1. And what is the exponent here of x? 0 actually, hey? So you don't have to add this, but we could say that that's actually what that term is. Alright, x to the 0. What is anything to the power of 0? So remember, 1. Okay, so guys, it's going from biggest exponent to smallest exponent, right? So descending order. Yeah? Okay, anything to the power of 0 is 1. Yeah, we find out these ones, guys. Yeah. Because you're looking at the exponent of the variable. 5 and then 3 and then 1 and then 4. So you're not looking at the actual numbers. The exponent, you're looking at the exponent. Well, not really, because you have a negative 4 and a 3 and then an 8. It's like that. Oh, yeah. All right, let's look at revision 3 quickly. I want to do these algebra questions with you. Thank you. Let's focus, please. I have already done that first step for you. And remember, when you are given any kind of question, you always have to consider about that, right? So we would have to think, okay, we kind of have to do what's at the top first, but we can't because they're not like terms. Right? I can't actually minus this term from that one. They're not like terms. Okay. So what you then have to do, and this is also a while ago, if you also got, if you have more than one term at the top and one term at the bottom, you split your fraction up. Okay, so I'm going to write that on the side. Please make a note. It's rather saying numerator more than one term. And denominator one term. Then split fraction up. Okay, so what you then do is you take each term in the numerator and you write it over the same denominator. Right, so the first term, 25x squared, 1 to the 5, over the denominator. Then I put a minus in between the two fractions because there was a minus there, right? So whatever that sign is, you put in between the three fractions. Your next term, 50x to the 4y, over the denominator. And now you're going to have to simplify each of those fractions separately. Right, you're going to have to do the division. So now let's take a look, guys. For the first one, sorry, are you all okay? For the first one, what is a positive divided by negative? Negative. What's 25 divided by 25? 1, hey, so you can actually, you don't have to write that one. Maybe if we end up with nothing at the top, we can put the 1. Okay, but let's see. For the 25, they didn't cancel each other out. Now let's look at the x's. Where do I have more x's? At the bottom. How many more? 2. So in my denominator, I'm going to have to have an x to the power of 2. What's happening with the y's? Where do I have more y's? At the top. How many more? 3. So I'm going to have y to the power of 3 at the top. You have to, guys. If you put that y at the bottom, it's wrong. Okay, or if you put the x at the top, it's wrong. Okay. Now what's happening in the next one, guys? A negative and then a negative at the bottom. What happens when you have two negatives next to each other? A plus, hey? So the next term is actually going to be positive. So what is 50 divided by 75? 2. Okay, so I'm going to have to put a 2 somewhere. Let's actually just do it like that for now, right? Because I don't know if my answer is going to be a fraction or just a whole, just one thing, not like a non-fraction. Let's look at the x's, guys. Do you see that we have 4 x's at the top and at the bottom? That's quite nice. What happens there? They cancel out. Good. Now what about the y's? We don't have more y's. At the bottom, how many more? 1. Hey, I have 1 there and 2 there. So 1 y must be at the bottom. And now I know that I can put that 2 just on its own. Alright, is that fine, guys? A question like this will actually cost a lot of marks. They will give you a mark for actually splitting the fraction up. So for this line. And then here, you could possibly get 2 marks for each fraction, but maybe they'll do a mark there, and then maybe 1 mark for that whole fraction. So this would be like a 4-mark question, which is quite a lot. All right, let's look at B. Another board math question. What did you do first, guys? Times. So I'm going to multiply these 2, and then I actually also have multiplication to do here, hey? What's a negative times a negative? Positive. Okay, so we have, what's 8 times 3? 24, and x times x is x squared. Plus, oh, actually, wait. I said the wrong thing, guys. I didn't see that square thing. Do we multiply or do we do exponent first? Bonus actually, hey, sorry, I didn't see that square thing. So, we have to leave that minus where it is. And then let's actually square that bracket first. What is negative 5 squared? Negative 5 times negative 5. 25, hey, positive 25. So 25. And what is x squared? X squared. Okay, you have to do the exponent before you multiply. So exponent before multiplication. And remember, guys, I have this minus here, so these are 2 separate terms. That's why what I do here doesn't actually affect what's happening here. Okay, you have to multiply these 2 together. That's something completely separate from this bracket. Okay, 2 different terms. So you simplify the 2 terms. Now do we notice that they are like terms, x squared and x squared? What's 24 minus 25? -1. So this is going to be negative. Do I change the exponent or the variable when I'm subtracting? No. It's just going to be negative x squared. Or 1x squared, but in your final answer, you must take that one out. All right, last, or not last question, next question. We're almost done. I think I'm just going to do these 5. Yeah, unfortunately, I'll be trying to work again. Okay, again, I have something in front of a bracket. Can I simplify what is in the bracket, guys, of these like terms? No. So I have to, just like in the previous question, multiply the 4x squared y by both terms in the brackets. Okay, what's 4 times 5? 20. X squared times x to the 3. Y times y squared. 5 to the 3. Right, that's multiplication done. Now, positive times a negative is a negative. What is 4 times 3? Well, x squared times x squared, x to the 4, but I still had a y, right? There's no y there, but I do have to put the y that I had originally. We can't do anything further because they're not like terms. Okay, so that's the final. All right, let's look at D. Okay, guys, just to help you understand D, I'm just going to actually write it out in full. You don't have to. But just to show you what you're actually doing, we have negative x squared that we're raising to the power of 7, right? So that actually means negative x squared times negative x squared times negative x squared. That's 3, and then how many must I do? Oh, 4 more, yes. Sorry, I meant in total. I meant to do 7. Hey, what do I have now? 4, okay, 5, 6, and then 7. Let's just check. Is that 7? 1, 2, 3, 4, 5, 6, 7. Yes. Now, guys, I'm not saying that you have to do that in a test or exam. I just want to show you especially the side of the answer. Thank you. What is a negative times a negative? So if I take these first two, right, and I times them together, what's that? Positive. So can I say that these two negatives actually cancel each other out? Right? Does that make sense? So the negative times the negative is a positive. Okay, so now what about the next two negatives? Same thing, hey? So the negative times the negative is a positive. The next two negatives are also going to cancel each other out. What is my answer going to be? What sign is my answer going to have? A negative. Okay. So guys, when you're getting a question like this, I want you to ask yourself, I have a negative, but now I have 7 negatives. Right? You don't have to write it out. If you want to, you can, of course, it will make it easier. But I want you to try and visualize it. If you have 7 negatives, every 2 negatives cancel each other out. Right? So the first 2, negative 1 and 2 are going to cancel out. 3 and 4 cancel out. 5 and 6 cancel out. Negative number 7 is going to be in your answer. Right? Does that make sense? Okay, so the answer is negative. And now what are we going to do with these 2 exponents? We're going to times them. Remember, when you have an exponent inside a bracket and outside a bracket, you times them together. So what is 2 times 7? 8. Okay, so the answer there is negative x to the power of 40. All right, last one that we're going to mark today is a fraction. It's also a fraction in algebra. But guys, you do need to know how to just subtract one fraction from another. And we remember what we have to do. Yes, what? Yes, we need to find the LCD, right? So what is the lowest common, remember LCD is actually lowest common denominator, so it's the lowest common multiple of the denominators. Okay, so I'm actually going to write that on the side. Just step 1 is to find the LCD. So what is the LCD? The lowest common multiple of 5 and 2? 10. Right? So the LCD in this case is 10. The smallest number that 5 and 2 can divide into. That's what we're finding, right? Now, guys, we need to change our denominators to 10. So that's step 2. Change all denominators. It might not always be 2. You can have 3. You can even have 4. All right, so all of your denominators you need to change to that LCD. And multiply. Okay, so we need to ask ourselves, the first denominator is 5. What does I do to 5 to turn it into times by 2? So what I do at the bottom, I have to do at the top. So that fraction, guys, is going to become, what's 2x squared times 2? 4x squared. This times 2 is not an exponent, right? Maybe it looks like it is, but it's actually I'm timing 2x squared by 2, the number 2. Okay, it's not an exponent. Over what's 5 times 2? 10. And that's what we want. Minus. The second denominator is 2. What does I do to 2 to turn it into 10? Times by 5. So I have to do the same thing at the top. So what is 3x squared times 5? 15x squared. Remember, it's not an exponent, it's a number 5. I'm saying 3x squared times 5. So 3 times 5 is 15. Okay, and the x squared is going to stay x squared. Over 10. Now guys, if you want to, if it makes it easier, you can actually write this as just one fraction with a denominator of 10. But you don't actually have to. Okay? Now what's 4 minus 15? 11. Okay. So negative 11x squared over 10. Can I simplify 11 and 10? Now guys, it's actually better if you put that minus in front of the whole fraction. Because if I'm looking at this line, it looks like we're saying what's a negative divided by positive. Which is what? What's negative divided by positive? Negative. Okay. Just try to remember to put that minus actually in front of the whole fraction instead of at the top. Okay. That last line is actually good. All right, I'm going to stop talking right now because there are 15 minutes left. Well, 17, 18. There is still quite a lot that we do have to mark. All right, so I'll see how I'm going to space that out for the rest of this week. It's just today, tomorrow, and Friday still, eh? Thank you guys. Right to events. So you're gonna have a handbag on. It's a Thursday, Friday, and a Monday, and then on that Monday you're gonna have time or something. So then you don't have to walk. Oh, funny. They are officially, but unofficially, you can stop having them. Because a lot, like half of the teachers are gonna be wrong. Okay, guys. You have to do all of 6 minutes. Alex, hurry. What is revision 7 like? You don't have to do 7, eh? Revision 7. Ooh, but there's quite a lot. Okay. Jaden, yes? Yes, I'm going to tell you now. So guys, this is what revision 7 looks like. Right? If you were meant to go up to the end of 6, guys, revision 7 is very long. I'm not going to ask you to do all of this for tomorrow. I would like you to go up until OWL. So those first three, okay, they're not actually very long. If you look like the more complicated ones only really start after hours. Okay, so you're doing those ones for tomorrow, please. Revision 7, A to L. Yes, can we make a note of that? Start working on that now, guys. You have 11 minutes still. I don't want anyone to pack away, please. You're all going to work now.